Hello everyone, very welcome to the ESS and Solar Solutions Lockdown Lab. What I want to show you today is this is my Miasole panel. It's a 125 watt CIGS panel, slightly different. I'm not going to go into the details. And then I've also rigged up, this is a mono panel from Victron. It's a 170 watt output panel. Now I'm going to show you quickly what they are producing. This is so far from less ideal, no real sun, nothing. So they're just sitting out here idling and ticking away. And they are just purely for my test bench at the moment. Now I don't know whether you can see, now this is the current output 15 watts from the CIGS panel. Let me just change. Less than an ideal viewing on this little screen, I do apologize, but that is 22 watt output from my Victron panel. Now what I want to demonstrate is I've decided to use my version of a quick leaf. So we're going to see what happens if we use this and we cover a part of this panel. So now we've covered the panel, and this is now my Victron panel, and suddenly it is dropped down to 18 watts. Remove it and it jumps up quite substantially. So a very small leaf makes a very big difference to the panel and its output potentially. Now this is the CIGS panel, the Miasole. Remember, it's only 125, so of course it's expected to produce a lot less under these conditions. But 15 watts, there you go, we've got our leaf, and we decided to cover it up. And it's only gone down to 13 watts. Somehow it's not affected as drastically by that leaf. But let's go a little bit bigger. Now you've seen this probably in my other ones. These are what I call my extreme leaves. So let's see what happens if we start using them. Right, so back to normal. We've removed the other leaves. Now we're going to use the big one. So this is the Miasole. This is my big leaf. And we've now placed that on there. And oh, it had an impact. We're down to about 10-11 watts production. Now that is quite staggering. It's not actually damaged the output as much as I would have expected. Now let us repeat that exact same exercise with the Victron. So currently, remember, 170 watt panel producing 22 watt at the moment. There's our extreme leaf. Oh no, it actually killed the panel completely. Now there you go. This is what it's all about, and I'll explain that a little bit later. But I want to take it one step further. Right, so I'm now back to my Miasole panel. Still far from ideal, overcast day. Nonetheless, we've got some output. We're going to play around. We added our one leaf. We already saw that it had some impact. Now I've added my two leaves. And we're actually still producing power. In summary, I wanted to show you two different technologies at work here. It's not about the performance of the panels, because that's an unfair assessment. But the copper indium gallium selenide, or the CIGS panel, is made up of all these cells, as you can see. It's a very lightweight panel. It's also flexible. But every two cells are connected with a bypass diode, and that's why you see the results you did. That means that if there is one cell or two cells affected by shading, it doesn't affect a whole string. Now you will see on the Victron panel, of course, here you have these strings. And if one of those cells in that string suffers, then the whole string suffers. So that's really, in essence, what I wanted to share with you today. So, of course, this is silicon. It's a 170 watt panel. This is a 125 watt panel. But nonetheless, I think there are some things that you can take out of the video. It was very impromptu. Now, until next time, I will leave you with that thought. I hope you enjoyed it. If you liked what we did, let us know. If you have some questions, maybe some comments, observations, I'd love to hear from you. So from the ESS and Solar Solutions Lockdown Lab with Etienne, until next time, stay safe and hope to see you again soon.